Moving on to cumulative frequency. Cumulative frequency is similar to regular frequency, where you have your number of times a number is appearing between a certain range or a certain value. The cumulative frequency is the running total as you start working your way down your table. So that's kind of what it looks like. So you can total these up as you go. Which can be helpful because you can determine how many values are above or below a certain range. So what we're going to do is we're going to construct a cumulative frequency table first. So in order to do that, what you would do is copy down your regular frequency table and then just add another column to it. So instead of redrawing it, I'm just going to add another column for the cumulative frequency. Cumulative frequency. Okay, so what you're going to do is you are just going to add your numbers as you go. So first row would be 1. Then I would add the first 2 rows, that would be 21. And then add the first 3 rows, that would be, 52? Then I would add the next one. So this would be 73. And then add your last one, which would be 80. So something that this can tell you is that you have 80 athletes altogether, if it didn't tell you that up here. And then you can determine where the majority of your data lies just by looking at these numbers. So I can tell that over half of my runners were below 30 laps. Okay, so that's how you construct a cumulative frequency table. Copy down the frequency and then add yourself another row and add up the running totals of your row. Next thing that we're going to do is draw a cumulative frequency curve. So you're basically just going to draw a graph. Okay, so on here, I'm going to go ahead and have my number of laps. And I'm going to do a cumulative frequency instead of the actual frequency here. So I know I'm going to have to go up to 80 and then over to 50. So let's see. So this is number of laps. And normally we're used to drawing frequency over here. Now it's going to be cumulative frequency. I'm sort of in the dark. There we go. Okay, so this is cumulative frequency. Okay, and we're gonna go ahead and add some to our picture. So 0, I'm gonna go 10, 20, 30, 40, 50 here. And then I'm gonna go up to 80. So 1, 2, 3, 4, 7, 8 is at the very top. There's 80, 40. Okay, so now I'm going to go ahead and plot my points and then go from there. So I'm looking at these numbers here and I'm going to plot them in my ranges. So 10, I would go to 1. Ooh, it's going to start out pretty low. And then to 21. And then 30 would go up to 52. 40 would be at 21. Sorry, no, 73. 73. And then 50 would be at the 80. So here's my curve. Okay. And that's what a cumulative frequency curve looks like. Okay. The last thing that we're going to do is on this is estimate the median and the interquartile range. So when we're estimating things here, we're not actually looking at the entire data set from a curve. We're just going to go ahead and have the idea that I know that Q1 is about a quarter of the way through, hypothetically, and right now we're estimating. The median would be halfway through, and then Q3 would be 75% the way through or 3/4 the way through. Luckily, we got some really nice numbers. 80 is a really good number to break apart into 4 equal parts. I'm going to start with the median. The median is going to be right at 40. So what I'm doing here is I'm taking my number of values. So the median is my number of values divided by 2. In this case, it is 80 divided by 2. That's going to be where the median is going to land. Okay, so then my Q1 would be 1/4 of the way through. So I'm going to divide it by 4. So 80 divided by 4 would be 20. So it's going to land roughly right here. It helps to have a ruler on this one. Q3, remember, is 3/4 the way through. So I'm going to go 3/4 of n. So 80 divided by, or multiplied by 3/4. So that would be at 60. So that would be here. Draw a straight line coming out and see where your graph is going to hit. So on this one, right, these are not my numbers that I'm looking for, right? This would be Q1. This would be the median. This would be Q3. The values that I really care about are the X values, right? Because those are the numbers that are my data set. So what I'm going to do is I'm going to drop a vertical line where my horizontal line hit it. And that's going to be where my value is estimated at. So it looks like Q1 maybe is around like 18. I mean, having it on an actual graph is a lot better. But let's just go ahead and take a guess. So we'll say Q1 is 18. Drop your median down. I don't know, like 25. It's kind of hitting right in the middle. It's a hand-drawn graph. So Q2, or the median, would be 25. And then drop this last one. Maybe like 34. Q3 would be 34. So I got the median. 25 is what I think it's going to be. And then my interquartile range, I'm going to subtract my two numbers. So 34 minus 18 would be 16 altogether. So those are my two estimated values. So you're chunking your graph up into 4 equal parts, right? So you divide your total number of terms, or your highest value of your cumulative table, and you divide it in half, you divide it in 1/4, and you divide it in 3/4, and that's going to give you your 4 equal parts, and that's where your numbers are going to lie.